Hey everybody, I hope you're doing well. In this video, I want to talk about how to use integration to find the area between two curves. So let me jump right into the problem. Okay, in this particular problem, I have two curves. They're both parabolas, and they're both facing up. I want to figure out the area of the region that's bounded. So the first thing I'm going to do is put in these functions into Mathematica, and that's a fairly standard thing. Remember the clear command. It's really important to do that. So I always like to double check to see if I have the correct functions in there. It looks like I do. So I have two parabolas that open up. Now, is it possible that these parabolas only intersect at one place? Maybe never. And if they only intersect at one or no places, then I won't have a bounded region. So I want to actually figure out if I have intersection points here. So the first thing I'll do is I will evaluate these and the intersection points. How do we figure out intersection points? The solve command. So I'm going to try the solve command here. And let me evaluate this. And I wind up getting two values, so this looks promising. X equals 2 and x equals 3. But in order to make sure that I'm in the right area, no pun intended, I'm going to plot the two functions. I'm going to plot f of x and g of x. And I'll plot them from, let's say, 1 to 4. Because 1 to 4 contains 2 and 3. Oh, I got a mistake here. I saw the red. I'll evaluate this. And I'm looking at this and it's very, very hard to see. Let's just go from 2 to 3. And see what happens. Okay, there's a very, very small area in between them. You see that little tiny sliver? I have a top curve and a bottom curve. So which one's the top curve? It's the F or is it the G? Well, let's take a look at 2.4. Just to see which curve is on the top and which is on the bottom. Because I'm going to need that to figure out a vertical length. I need a top and a bottom. So a little bit more work. I'm going to compute F of 2.4. And I'm also going to compute G of 2.4. 13.96 is bigger than 13.72. So that says the curve F, the one defined by F, is on top. So the area, this is actually fairly straightforward here. I'm going to integrate, capital I, integrate f of x minus g of x. And that's going to go from x equals 2 to 3. And there's my entire syntax to do integration in Mathematica. I'm going to evaluate this and I get an area of 1/6. So this little tiny region has an area of 1/6. So I hope that very short demonstration helps you out with the area between two curves. A quick little recap. I first set the problem up by entering in the functions. Then I determine where they intersect. I really want to get a little picture of this, and it's hard to see here, but I do have one curve on top of another curve. One curve is always larger than the other curve. Now to determine which one, do a quick little check. Pick something on the interior. I picked 2.4. I'm going to evaluate f and g at 2.4. Whichever one is larger, that's the bigger one. The integrand, f of x minus g of x. And I'm going to integrate this from 2 to 3. My final result is an area of 1/6. I hope you found this video useful. If you have any questions, let me know. Have a great day. Bye.